Now we want to look at how significance, in terms of significant figures, plays into our world of unit conversions. So some unit conversions come from the definition of a unit, and this makes them exact. So all of the customary units where you define, for example, that there are 16 ounces in 1 pound. That is a counting-based description. It is exactly 16 ounces in 1 pound. It is exactly 32 fluid ounces in 1 quart. So those numbers are exact. When you are doing work with them, when you're doing math with them, you would not count their sig figs in terms of rounding your answer. The same thing is true for all metric to metric conversions. Anything based off of a prefix, that's a definition. So those are exact numbers. There are exactly 1,000 grams in a kilogram. 1,000 of anything in a kilo of the base. Kiloliter, kilometer, it's kiloseconds. It's always 1,000 in there. Where you have some significance, some measured values, is when you're converting between customary and metric. Okay? And so if you're looking at something, for example, 1 centimeter, how many inches is that? Well, there are people who literally do experiments where they find 1 centimeter, they get really precise measurements of 1 centimeter, and they see how many inches that is. And so you could imagine you are told that 1 centimeter is 0.3927 inches. The 1 on the centimeter is exact, and the non-1 value, the 0.3927, is inexact. So that has 4 sig figs. We could also go the other way. 1 inch is 2.54 centimeters. The value that has a 1 is always going to be exact, and the other value is always going to be inexact. That has, and you can tell by how many sig figs it has. So you would want to use that to count how many sig figs you need for rounding. Let's take a look at an example where we apply it. Office water cooler is about 5.0 gallons. What is this volume in liters? Start off by asking, what units should your answer have? Again, in the case of unit conversions, I'm going to key in on what unit doesn't have a value. So what is this volume in liters? What units do you start with? Well, liters is a volume unit. I have another value in a volume unit. It is my 5 gallons. So I need to relate these. We saw previously when we worked through metric, you can come up with that on your own. You can, figure out based off prefixes what the metric conversion factor is. When you're converting customary and metric, just look it up. Don't need to memorize these. You do not need to memorize these. You just need to be able to use them. And so we get 3.785 liters is equal to 1 gallon. That's a conversion factor that we can use. Office water cooler is about 5 gallons. What is this volume in liters? So we know what we want is liters, and what we have is gallons. And so what we can do is we can follow this strategy. We know we're starting here. So I have my 5.0 gallons. I know in the end, I'll give myself plenty of space. I want liters. And so because that is what I want, I can figure out that this needs to be liters. Whoa, whoa, whoa. This needs to be gallons. Whoa, Ben. That's gallons. So I need to cancel out that gallons and go in to liters. The bottom is always what you want to get rid of. And the top is where you want to go. Okay, so we want to go to liters here because we know that when we take this, we multiply by the top, divide by the bottom. And so what functionally happens is that gallons and that gallons would cancel out, and I would be left with just the liters for my units, which is the goal. So then the question is, again, what number of liters is equal to what number of gallons? And so we saw previously we could use metric definitions, but because we're going to be able to recognize that this is metric and this is a customary unit, when you're doing that sort of relationship, you need to look that up. So because you're doing this sort of relationship, you want to look up the relationship. And so what we could find is that 1 gallon is equal to 3.785 liters. And so I do want to know, where is it? There's on the slides, I've given, this table has a lot of customary to metric conversions. There's also some extra ones that I've put on Blackboard. You can take a look at all of these, but again, these are generally the only thing you're going to need. And some of these are double dipped, yeah, gallons to liters is in both of them. And so you can use this to relate your metric units and your customary. And we need to always look these up. There's no reason to memorize these. That is not a useful endeavor. It's going to be much more efficient just to go ahead and just look them up because they're seemingly random numbers. If you teach this class for like 4 or 5 years, you can start to memorize that one. So we want to take those and take these numbers. This is our defined relationship. So keep the numbers next to the unit. So gallon was on the bottom, so the 1 stays on the bottom. That means the 3.785 goes to the liters. Okay, so we can evaluate that arithmetic. What we're actually going to do in terms of multiplying it out, right, is we take this number, multiply it by the top, divide by the bottom. So what that's going to look like is we'd have 5.0 times 3.785 divided by the 1. Okay, so that's the actual math that we do in order to evaluate this. And once we do that, we get 18.925 liters. Which is great. We've gotten our answer. But this is not done. This answer needs to be rounded. We started with about 5 gallons, about 5.0 gallons. That word about implies that there is a rounded nature to this, right? It's not 5 gallons, it's about 5 gallons. So your answer, 18.925. There is a lot of information after that decimal. It would be kind of silly to say about 18.925 gallons. That is a very, very accurate measurement. There's a lot of information after that decimal. So we need to round based off of that. And we can see that what we're doing is multiplication and division. So we're going to round by counting up the total number of sig figs in all of my values. So I can see 5.0. We know the 5 is going to be significant. The 0 is trailing, so that's going to be significant because there's a decimal. So that's going to be 2 sig figs. 3.785, those are all non-zero. That is 4 sig figs. Then we have the 1 on the gallon. We may be tempted to call that a single, like a 1 sig fig, but this is exact. Whenever we're dealing with metric to customary conversions, basically how we can interpret this is that exactly 1 gallon is approximately 3.785 liters, right? That's the relationship, that exactly 1 gallon is approximately. So this would really be 1.00000. So we're just not going to worry about counting that 1 as far as sig figs go. So we can see we have 2 sig figs, 4 sig figs. We need to round our answer 1, 2 on that 18. You can see the next digit is a 9. So we're going to round up, and the correct answer would be 19 liters. So the volume of this water cooler is about 5 gallons or about 19 liters. Again, we want to round to represent that. You wouldn't say, it's kind of silly to say about 18.925. That is a lot of information to have the word about in front of it. That doesn't really feel like that much of an estimation. Let's do another example. Daily water usage in the United States is 5.0 times 10 to the 5th milliliters. What is this quantity in gallons? What units should your answer have? Again, we're going to key in on one. It's also a separate question. That's another thing we can see. That is explicitly, what is this quantity in gallons? And so, you don't need to, we can really use the language when we're reading problems to really parse out what should the answer look like, right? And you can kind of instinctively pull these things out. And one of the purposes of pointing it out in a problem where you can instinctively pull it out is to recognize what patterns you're using. So that way, when some of the language is new and chemical and technical, you can still rely on those same patterns. So we want gallons. We are starting with milliliters. So then what conversion factors connect to those start and end points? That's going to be a bit more complicated. So let's take a look at how it goes. Daily water usage in the United States is 5.0 times 10 to the 5th milliliters. What is this quantity in gallons? So what I want is, I want this volume in gallons, and I'm starting with a volume in milliliters. So to set it up, we know this is a unit conversion problem. We can approach it how we've approached these other ones. I'm starting with my 5 times 10, whoopsie, that is 5.0 times 10 to the 5th milliliters times something is gonna equal gallons. Okay, so I can try milliliters, gallons. Follow the strategy, the approach that we've discussed previously. And so if we want to fill this out, we're going to be thinking about, how many gallons is equal to how many milliliters. And how we have approached filling in those values is by asking really, what are the differences between them? Previously we saw you were 2 metric units, so you could look at the approximation, or these metric customary. So again, we can see metric unit, customary. So that means, well, let's look it up. Right? We would look up the relationship. We can find what it is. So I turn here. Volume, I got liters to gallons. Milliliters to cubic centimeters. Gallons to liters. Cups to pints. None of those are really going to help. So I know none of them are quite what I want. So unfortunately, this isn't going to work. I can't just do this in one step because I don't have access to a direct gallons to milliliters conversion. What I do have is a gallons to liters conversion, which at least would get me from customary to metric. So what I can do is I can rewrite this. Okay? I'm going to need to do something a smidge more complicated. I'm going to start with the same 5.0 times 10 to the 5th milliliters. And I know in the end, I still want gallons. But what I'm going to say is I'm going to start back here. And I'm going to say, okay, well, what relationship lets me get gallons, which is what I want? We know that the last, this conversion factor needs to have gallons as its top unit. And we can see that gallons, we can relate it into a metric unit by relating it to liters. And so I know that 1 gallon is 3.785 liters. So we've seen that right here. Right, we can pull those numbers off. The 3.75 goes to the liters, which is on the bottom. Perfect. So then what I can say is now I have a ton of space for this conversion, which is going to be a metric conversion. And what I can see is, in order for this to work, I still need to get rid of milliliters. And what I could go into is liters. Because we know what will happen is this milliliters cancels this milliliters, this liters cancels that liters, right? We're doing this first step. We go from milliliters to liters. Then we go from liters to gallons, and that would cancel out. And we can figure out this is a metric conversion. We can use the fact that 1 liter is 1,000 milliliters. So functionally, if we want to see how this kind of arithmetic is actually going to work, for our units, the multiplication is we take it, we multiply across the top, and then we divide everything on the bottom. So ml times L times GAL divided by ml and L. Right, that's how all of our units combine. We can see that it's going to be those cancel, and what I'm left with for my units is going to be just the gallons. And for the arithmetic, I use the same pattern. The 5.0 times 10 to the 5th times 1 times 1, and then it's going to be divided by both of those numbers. So the arithmetic would be that you'd actually like plug in to your calculator or do by hand if you're feeling adventurous. Is going to be this, right? The 5.0 times 10 to the 5th times the 1 divided by 1,000 times 3.785. And when you plug that in, you get 132.1. Which is great, that gives you the right size. The thing is, that number needs to be rounded. You need to count the sig figs of your input values. Okay? So 5.0 times 10 to the 5th, because this is in scientific notation, those two digits are significant. 2 sig figs. This is a metric conversion. This is a definition. So they are both exact. Metric to metric, customary to customary. If you're not changing the system, then they are both going to be exact. Here, customary between customary and metric, the 1 is always exact. That is not. That is 4 sig figs. So the measured value. So we're going to round to 2 sig figs. 1, 2. We're going to round the 3. You can see that the next digit is a 2. So we're going to round down. And the answer is 130. It doesn't become 13 because that would be an entirely different size. We just don't know what that 1's digit is. We only had 2 sig figs to start with. We need to maintain that. So we can go through this process, you know, and we can go between, it's a bit more complicated because we're using 2 steps, but that's fine. We can work through it and we can make that happen and use this as a method. And again, you don't have to go through all of these steps showing all of this. Showing this wouldn't be necessary, but you do need to show how you're going from milliliters to gallons. And you do need to get, you know, round your sig figs and show your units. When we're looking at the answers, I'm looking for, is this number the right value? Is it rounded to the correct number of sig figs? Does it have the correct units on it, right? When we're showing our work, are we using, you don't have to show counts on all of these, but are you showing the conversion factors that you're using? Are you using them correctly? All of those sorts of ideas. But we can also see that on average, people use 130 gallons a day of water in the United States, which is a lot of water.